We're going to continue the second half of the study guide. In this case, the first question was number 9. So it says if Mark wants to graph the solution to the systems of equations below, it's referring to these two right here. Which of the following graphs would represent the solution, right? So in this case, I could see that the system's already set up in standard form in this case. So I'm actually going to divide both of these equations into two parts in this case. And so I'll have 3x plus 5y is equal to 30 over here. And then I have to think about two things. Since it's in standard form, I would take the approach of finding the x and y intercepts of both and identifying which of these graphs would identify the system. So in this case, if I'm trying to find the y-intercept, right, I have to set x is equal to 0. So I would have 2 times 0 minus y is equal to 7. So again, negative 1 y is equal to 7. And negative 1, so y is equal to negative 7 in this case. And then if we want to find the x-intercept now, we set y equals to 0. So we get 2x minus 0 is equal to 7. So we get 2x, that cancels, is equal to 7. Divided by 2, x is equal to 3.5 in this case. So we get is equal to 3.5. So in this case, I found essentially the y and x intercepts for these, and it's saying that it would be at in this case we would have in this case we would have the y-intercept being at the negative 7, right? So it looks like maybe this one is going down through negative 7, but it's not going through 3.5, so it doesn't seem like that one. And then y is equal to negative 7 seems like it's down here, and then 3.5. So it looks like that one might be it. This one doesn't have any, so that one could be deleted. Y equals to negative 7. Doesn't seem like it's this one either, right? This is a negative 1 here, so that's not it. The negative 1 as well. So let's just keep going with the second equation. Let's see. So again, same thing. If I wanted to find the y-intercept in this case, I would set x is equal to 0. So I would get 3 times 0 plus 5y is equal to 30. These cancel out. You get 5y is equal to 30 divided by 5. Y is equal to 6 to this one. And then when I'm trying to find the x-intercept, again, y is equal to 0 now. So you get 3x plus 5 times 0 is equal to 30. And these cancel out. We get 3x is equal to 30. Divided by 3x is equal to 10, right? So now, for this second one, I'm going to make it in blue, right? So we could kind of distinguish it. So y is equal to 6. Let's start with the one we think it is. We'll see. Y is 6 and x is equal to 10. So it's actually, I found that this is the actual one that locates the other ones. They try to do y is equal to 6, this second one, but this is a negative 10, so it's not right. So confirms it. And then we have negative 6 here. Is one that, so that doesn't work. So confirms it's not that one. Right, so I could kind of use the elimination process and see the only one that matches. And this here will be C, right? And the answer, the point of intersection in this case would be at 5, 5, 3, it looks like. So that's one way we could do. You just kind of find in this case, that we're in standard form, right? So we just find the x and y intercept. This next one, we're kind of reading, interpreting this graph that's given to us. So it says tickets to the zoo cost $12 for adults, $8 for children. The school has a budget of $240 for the field trip. Okay, so it says an equation representing the budget for the trip is 240 is equal to 12x plus 8y. And it says here's a graph that represents this equation. So this graph right here that they're showing us is representing this equation. So now it's telling us to select all of the true statements that would be involved, right? If based on the graph. So the first one, this first statement says if 10 students. So first let's identify who we have. The number of adults is represented by the X. The number of children is represented by the Y, right? So that's important right here, right? It's represented by the Y axis. So if 10 students go, so that means if 10 children goes, right? 13 adults could go. Well, let's see if that's true. Well, if I have 13 kids, right? Here's where it's going to intersect on the graph. And this is if 10 students go, then we could see that we have about, in this case, right, we have about, that point means somewhere in the middle. So yeah, it's about 13. So this one would be, yes, that's true, right? So yeah, that one would be correct. Now let's erase that again. Now looking at the second sentence says if no adults go, so that means if 0 adults go here, 20 students could go. Well, if 0 adults go, right, that would be 0 for the X. The maximum amount would be here. That means that 30 students could go. So this one will be false, right? It's not 20. This will actually be 30 students. The third one says, let me erase this again just so that I don't confuse that. Now the next statement says, it says if 4 more adults go to the zoo, that means that there will be room for 6 fewer students. Well, if zero adults went, we determined that it will be 30, right? Well, they're saying, well, what about if they had 4 more going? Well, if instead of 0, 4 went, right? That means that only 24 students could go, essentially, right? So if it was 0 adults, it was 30, and now if 4 adults go, it's 24. Well, that means that they went from 30 to 24. So that means that, yes, there are 6 fewer students that will be able to go. So that one is true, right? And then the next one says if 8 adults go to the zoo, right? So now they're saying again the specific. So 8 adults go to the zoo, then 18 students could go. Well, in this case, right, 8 adults go. It means that 18 students could go. So yes, that one's also true, right? And then lastly, it says if 2 more students go, that means that there will be room for 3 fewer adults. Well, if 0 children go, right, how many adults could go? Well, we could see it's about 20 in this case, right? Well, it says, well, what if 2 more students go? Well, instead of 0, what if it was 2, right? Well, if it was 2, it would be somewhere there. So somewhere around 19, right? So we'll go from 20 to 19. So it wouldn't be 3 less adults. It would just be 1 less adult. So this one will be false. So the only answers were the first one, the second one, and the third option for this one. So it's important that you're just interpreting the graph, right? They love asking you guys questions around this, so make sure you guys are ready for a question like that. And then for this one, I'm gonna actually skip to 12, and then I'll come back to 11, just because that one takes a little longer. But we'll finish with that one. So at this point, it says, a phone company charges a base fee of $15 per month, plus an additional charge per minute. So it says the monthly cost, C, can be represented by this equation. So here's the equation. C is equal to 15 plus A times M. So it says where A is the additional charge per minute, M is the number of minutes used. So it says which equation can be used to find the additional charge. So in this case, they told us that was A. That means we're solving for A per minute if we know the values of M and C. So in this situation, right, we already have this equation here. So C is equal to 15 plus A times M. And they're saying, hey, if we look at the answer choices, all of these are the equations equal to A. So that means we have to solve for A here. So that means we have to move the 15 and the M to the other side. So we have to figure out how we do that. Well, the first thing is the 15 is not attached, so we could just subtract 15 to both sides, right? So that leaves us with C minus 15 is equal to A times M. And again, we're solving for A. I want A by itself. And currently A is multiplying by M, so I need to take the inverse. So divide by M, and that allows me to cancel those off. And it leaves me with A is equal to C minus 15 divided by the minutes. Okay, so in this case, this would be the final equation. That one would match with our second option here. So it was option 2. The last question was 11. So it says select all the equations that are equivalent to this equation right here that they give us, right? Everything has to be equivalent to that. So in this case, one of the things that we have to think about is that we could manipulate equations and still keep them equivalent as long as we're always keeping in mind that whatever operations we're doing to the left-hand side of the equation has to also be done to the right-hand side of the equation, right? Or kind of pay attention to what's happening within our answer choices in this case. So I'm taking this equation, right? And now having to think about, well, what happened from the original equation to my answer choice, right? So in this case, if you look at this, the only difference is that this 3 is now gone. It's no longer there, right? So I have to think about, well, what happened in order for them to do that? Well, I kind of did it over here, right down here, so you can kind of see, well, what they did was that they got rid of this 3 right here. Well, what's the only way they could do that? Well, if this whole thing was being divided by 3, the only way you could get rid of it is by multiplying by 3, but you have to do it to both sides, right? So this allowed it to cancel, which left only this here. But now this 3 has to get distributed to the terms in the outside, right? So in this case, 2 times 3 gave you 6. 3 times negative 1 gives you negative 3, right? And that's how they got the first. You could see that this was the step right here, right? Where we see that the first option is actually equivalent. So all they did was multiply this 3. And once they did that, it allowed you to just be at this state of the process. So A was correct. The second one, where we have 3x minus 9 divided by 3. So in this case, they preserved, right, this side. They didn't do anything to it for option 2. And then now have negative x minus 2. Well, I'm going to ask myself, well, how did they get from here to negative x minus 2, right, to here? And well, in this case, what they did was that they simplified. And again, I have it down here. Right, so for number 1, it was just that stage. Number 2, again, they left the left-hand side the same, right? But we have to get to this negative x minus 2 here. So the way they did that, it was just they distributed this negative 1 here. So they got negative 1x minus 4. And then we could combine the like terms with the 2 and the negative 4. So we get negative x, or negative 1x minus 2. So the second one was also equivalent. The only thing they did was that they simplified this side over here by distributing this negative 1. right? So the second one was also equivalent. Now looking at 3, right? So again, thinking about what's the difference between this one and this equation, the original, and then this one, to see if what they did to be equivalent. So again, we're kind of seeing here the right hand side is the same, so they didn't seem to do anything here. But this side is different now. The left hand side is different. So if we look, zoom back in here, they started here and then they end up here, right? Well, how did they do that? Well, in this case, let me see, just look at this. Yeah, this one says the same, right? So they stayed up to this point right here, right? So we're trying to go from here to here. Well, they didn't really do anything to this left-hand side. So again, that's where it stays here. But then what happened there, right? Well, the thing is that they just simplified the left-hand side of it. So they did 3x divided by 3, that gives them x. And then negative 9 divided by 3, that gives you negative 3 here. So that's all they did. They just simplified the left-hand side. So that means that in this case, right, in this case, all they did was simplify this left-hand side. Again, like this. And then you get the x minus 3 here. So that one was correct, right? Now, looking at the next option here, same thing. You only have the 3x minus 9. So it had to multiply by the 3 again. And then how do they get negative 3x minus 6? Well, let's zoom into that one, right? Let's see what they did. So for 4, again, they're going from this to this. How do they do that? Well, they multiplied by 3 to both sides, right? So in this case, we already had established that this one right here was true, right? So again, they multiply by 3. So we know that x minus 3 is equal to negative 1x minus 2. So in this case, right, what they did was 2 things. So let's go back up. So the first thing is they multiply this by 3, right? They cancel this, so 3x minus 9 is equal to, again, this is a negative 1, so 3 times 2 is 6. 3 times negative 1 is negative 3. And then x plus 4, right? That stays the same. And then we have this side, so that looks good. But how do they get this? Well, I think they just simplify this further. Let's check, right? So if we simplify this further, we get 6 minus 3x minus 12. Again, I'm just distributing this 3 to both of these. These are like terms, so we get 3x minus 9 is equal to 6. Actually equals to negative 3x. And then 6 minus 12, that gives you negative 6. So yes, it checks off. So that one's correct. And then the last one, well, this one and this one are very similar, right? But we already established that this was correct, negative x minus 2. So there's no way that anything could happen, right? If this is staying the same, where these are going to be actually equivalent. And again, in this case, right, we could kind of look at the last one. Again, they left the left-hand side the same, right? They didn't do anything to this. It was just this side. And again, when we simplified it, we got that this was the correct simplification. But this is where it's asking if it's equivalent. Well, these two didn't match on the right-hand side, so therefore these are not equivalent, right? So we could prove that they're not. Right, so this one's false. So we could say that that one is not equivalent. So again, at this point, make sure you guys go through all these equations. Take a look at what standards they belong to. If you're not sure, come and ask me, right? We could figure it out. And then you guys can make up any problems that you missed if you already took the exam, or trust me, this study guide will help you tremendously to get ready for this Unit 2 exam and minimize the number of questions that you will have to reassess on afterwards.